Alright, so today we're going to start working with some problems that involve work, potential energy, rearranging equations, that sort of thing. Alright, so first thing is using your PE equation, but maybe solving for a different variable. So like, let's say you have to solve for mass, okay? What does the equation look like solve for mass? So if you want to get mass by itself, that means you need to get rid of the gravity and height. So you divide by GH on both sides. And you have M is equal to PE divided by GH, right? Or the other thing you might need to solve for is H. So again, starting with PE equals MGH, we want to get rid of the other two variables, mass and gravity. So you're going to divide by mg, all right? And then you'll have height is equal to PE divided by mass times gravity. Now remember, mass times gravity is also weight. So you could also solve for height by having PE divided by weight. Okay? Now that W is for weight, not work. Okay? So, an example of when you might need to know this. What is the mass of an object that has a potential energy of 30,000 joules and is 15 meters in the air? So we know our height, we know our PE, and we want to know our mass. So we know PE, 30,000 joules, height is 15 meters, G is a given, you should always know that, and M is question mark. All right, so we just rearranged for M on the last slide, so it's going to be PE divided by GH. So what that's going to look like is 30,000 joules divided by 15 times 10, which is equal to 200. And then your mass should be in units that relate to mass, which hopefully you are remembering are kilograms. Okay? So there's one sample problem. Just make sure you always remember to include that G. It's not going to be given to you in problems. You need to know. You need to remember that G is always equal to 10 meters. All right, another equation you might have is going to be PE and finding height. So we want to know how high an object is that has potential energy of 7,500 joules and has a mass of 25 kilograms. So our knowns equals 25 kg. PE equals 7,500 joules, and you also need to make sure you remember your G. All right, so our equation rearranged for height is PE divided by mg. All right, so if we're going to plug in our knowns, we're going to have 7,500 divided by 25 times 10, or 7,500 divided by 250, and that's going to be equal to 30. And your units, because we're solving for distance or height, is meters. Okay? Now, based on our lab yesterday, you should have seen that work is equal to potential energy. All right? So if you're given a work, you also know your potential energy. Or if you're given a potential energy, you also know your work. Okay? So this question is asking, what is the force needed to give an object 32,000 joules of potential energy when the force is applied over 80 meters? All right? So let's list out what we know. We know that we have a distance of 80 meters. The way it's written, it's not necessarily a height, okay? So we're just going to label it as a distance. We know that PE is equal to 32,000 joules, which also means work is equal to 32,000 joules. All right? So our question is force. So we want an equation that has force, distance, and then potential energy or work. And if you remember our work equation, work equals force times distance, that equation has everything we need. If we want to rearrange that to solve for force, you just have to divide by your distance. So force is equal to work divided by distance. So we're going to plug in our numbers. Force is equal to 32,000 divided by 80, which ends up being, cross out the zeros, 32 is going to be 400. And then since we're solving for force, your units are newtons. Okay? So, same thing, you can do that to solve for distance in the work equation instead of force. All right, so we have a potential energy of 42,000 joules, 700 Newton force, and we want to know our distance. So we know PE equals 42,000 joules, which also means work is 42,000 joules. All right, we know force is 700 newtons. Our equation, work equals force times distance. If we want to find distance, we divide by force. So D is equal to work over force. So we're going to plug in 42,000 joules divided by 700, which is going to end up giving you 60. And then since we're solving for a distance, your units are meters. Okay? So work and then finding height. So just like before, we know work is equal to potential energy. So if it takes 50,000 joules of work, that's going to give you 50,000 joules of potential energy. And we have a 500 kilogram object. What is the height of the object? All right, so we know work is 50,000 joules. We know that PE is 50,000 joules, since those are always going to be equal to each other. Then we know our mass is 500 kg. And then don't forget, and you could have listed this as a known last time, it's just you ended up not needing it, but something that you'll always have available to you as a known is G is equal to 10 meters per second squared. All right, so we want an equation that is going to help us find height that has some of these variables in it, which is our PE equation. PE equals mgh. We want to find height. That looks like PE divided by mg. So we're going to have 50,000 divided by 500 times 10, which is like 5,000, which ends up leaving us with 50,000 divided by 5,000 would be 10. And then since we're solving for a height, your units are meters. Okay? Then last thing you might end up seeing as far as a problem goes is you're given work, you have a height, and then you want to know the mass. So we know work is 28,000 joules, and since work and potential energy are equal to each other, our PE is also 28,000 joules. All right, and our height is 40 meters. And another known you can always include, whether or not you need it, is G equals 10 meters per second squared, though we will need it for this one. And mass is our question mark. So work equation doesn't help us because we need a force to find a distance. So we're going to again be using our PE equals mgh. All right, and then we're going to solve for m, which looks like PE over GH. So we'll have 28,000 divided by 10 times 40, all right, which is also like 400, which is going to give you 70. And if you're solving for mass, that's kilograms, okay? Now you notice the question also said, what is the weight of the object? So you can either solve for mass straight out, and then to figure out your weight, you just have to multiply by 10, or you could have not divided by 10 in the first place. But either way, the weight, or force of gravity, is equal to 700 newtons, okay? So mass is in kilograms, that's a mass, that's your weight, okay? So make sure you get your online assignment done. It's due by tomorrow morning, 7:20 a.m., and I will see you in class.